Hi, Will Brewer here, HVACR Application Engineer with ABB. And in this video on adaptive programming, we're going to take a look at the logical function blocks. When you open adaptive programming and you are ready to use some digital or Boolean logical programming, in the function block group, you can scroll over to the right using the slider on the bottom and access more of the function blocks to the right. Here we have the standards that you would use for Boolean logic. The AND block can take in 2 digital inputs to start, and if you needed to compare more functions, you could have a second block where you take the state of this AND block and run it into another block to compare to something else. If you were trying to get the state of 3 AND inputs or more, the AND block has a nice feature where you can mouse over the dark gray bar on the bottom and drag it out to take up to 8 inputs. So instead of needing a separate AND block, you can just increase the number on a single block. The same function is available with the OR block. Up to 8 inputs could be ORed together to create one output. We also have access to the XOR block, or the exclusive OR block. This block outputs a 1 or true value when either input 1 or input 2 are not equal to each other. For reference, if you ever need a guide or help information for any of the function blocks in adaptive programming, I recommend using the Adaptive Programming Application Guide that I have a link to in the description below. This guide is a great tool for adaptive programming to easily reference the function blocks, inputs or outputs, and the rules used by adaptive programming to complete that logic. The NOT block is available in the logical blocks. This block simply inverts the state of its input to its output. You might see this block needed if you are comparing one state to another and need to switch its inputs. This block would be easier to use to show graphically when you are using a NOT block. Alternatively, a Boolean input has in front of it a dash. This can be clicked and changed to a circle, which is the same function as a NOT block. So now the opposite state of this input will be true for this AND block, or now it is the normal state. The trigger up block is a rising edge block, or a one-shot output. It will only output a value of 1 when the previous input had just changed to a 1, and then on the next program run will be a 0 again until the input value goes back down to 0. The trigger down output is similar, where a value has to go from a 1 to a 0 to output a 1, but on the next program run it will reset to 0. This is a good point to bring up the base program in adaptive programming running in an ACH580 has a program runtime or program cycle time of 10 milliseconds. That means the program will run through all of your blocks one time once every 10 milliseconds. So that's important to know that your program will run 100 times in 1 second. If you needed a value or state to go true once on an event instead of being repeated every time the program run, that's how you do a one-shot on a trigger. Our next block is the SR, set release block, or also known as a latch. When this value to the set input goes true, the output will stay on until the reset value goes true, which will then allow the output to go off or 0. And the last blocks are the bitwise AND, or XOR function blocks. I personally haven't had a use for these, but they would be used for taking in a numerical value from a drive parameter with several different sub-bit values corresponding to different states. There, this block could take out which value is true of the bit and then output that value to be read by another block in the program. Again, if you're looking for any more information on any of these blocks, the application guide for adaptive programming is a great reference tool. Now, to test out simple programming for logical blocks, all we need to do is connect up a couple inputs and outputs to show our state change. If we just compare a couple of the drive digital inputs, we can show how when one or more states is true, when that will write to a defined output. So let's take a couple of the drive digital inputs, and we will write to the drive's default start command from ext in 1. Now, adaptive programming, when it writes to an output value, that control takes priority over the input programmed in the parameters. If we download to the drive and run the program, our value to ext1 in command is 0. If we go back and look at the parameters, you can now see that it's automatically changed the source for ext1 in source to adaptive programming. Now, as I turn on the digital inputs, the drive has started running once all 3 inputs are true. This has taken precedent over the default programming for the other inputs, again, with adaptive programming's output having priority. When taking one of the 3 inputs away, the command returns to false. And that's it for a simple logical block programming. Once again, for further tips or help information, refer to the Adaptive Programming Application Guide. If you would like to learn more about adaptive programming, check out the videos linked in the description below. And if you have any further questions, feel free to reach out to your local ABB representative.